Okay, we'll start our class now. Okay, so Assalamualaikum, good morning everyone. So before we start the class, one good news and one not so good news. So good news is like I tested for COVID yesterday and it's negative. So it's not COVID. So hopefully it's just a regular sore throat and also the fever. The not so good news is that regarding your test. Okay. So about your test, it has been postponed. It has been delayed because of certain things that happen. Not my fault. Okay. So your new date for your test two one is not right anymore. Where it is? Okay. For your test two, it will be instead of next week, it will be next 2 weeks on 10th of July. Okay, on week 8. So on week 8, so today is 27, right? 27th of June. Um, instead of next week on 3rd of July, you guys will be having your test 2 on 10th of July. Okay, 10th of July 2024, Wednesday. Why did I write the time here? So the time would be 8:30 until 10 p.m. Okay, it will be 1 hour and a half. Okay, instead of because in test one you have 1 hour 15 minutes, right? But for test two, you guys will have 1 hour and a half. Okay, 8:30 until 10 p.m. The location will still be the same. In the library, it will comprise of chapter 3 and chapter 4, and it will be 20% of your final grade. Okay. So this one is the change, which is from 3rd of July to 10th of July. Okay. And then for your quiz 2, I will still proceed. The quiz 2 on this Sunday, this Sunday class. So your quiz 2, today is Thursday, so it will be on 30th of June. Okay, your quiz 2 will be 30th of June. Will be 1 hour and it will be chapter 3 and chapter 4 as well. Okay. This one will carry 2.5% of your final mark lah. Okay, Sunday class will be on 30th of June. Okay, so that's the news lah about your test 2 and quiz. So is there any questions about your test 2 or quiz 2? No question. If there's no question, we can continue with our class today. Our class today will probably be only uh, will probably only meet on the first half. For the second half, I'll let you guys off with if you guys want to do the exercise in the book, or if you guys still haven't done the exercise that I've gave. Yeah. Okay. If I record this. Okay. So for today, what we're gonna do is we are going to look at the past year's questions. Okay. See the concept or the pattern of the past year's question, and then see how are we going to tackle the questions lah. Okay. So let's dive straight into it. So this one is the question from last year, okay, 2023, 2024. Okay, and so if you see a question like this, right? So you know that it is regarding a probability. Okay, why? Because the question asks you, okay, find the probability. Okay, find the probability, find the probability, something like that. Okay, so how do you guys want to know if whether the probability that they're talking about is about the discrete or continuous or discrete uniform or binomial or call it a Poisson distribution and also later normal distribution. Okay, so you guys need to know when does this type of distribution occurs. Okay, so read the question and then see what kind of information was given to you. Okay, because based on those kind of information, you can classify which distribution does the question follow. So in this case, take a look at this. Okay, so past records indicate that in a large restaurant, 3 out of 5 customers ask for water with their meal. Okay, so we have 3 out of 5 customers. Okay, so 3 out of 5 customers, what we can get from that is the probability of success. Okay, probability of success, whether the customer asks water for their meal. Okay. Let's continue reading the question. If a random sample 10 of customers is selected, you need to find the probability that exactly 6 customers ask for water with their meal. Okay, ask for water with their meal. Less than 9 customers ask for water with their meal. Between 3 and 8 customers do not ask water for their meal. Okay, so here in the question, ask for water with their meal, right? And then in the question above, it also stated that ask water. So what we can do is we know that there are 2 different outcomes, whether the customer asked for water with their meal or the customer did not ask for water with their meal. So what we can do is write X. X is the number of customers ask water with their meal. Okay. X is the number of customers who ask water with their meal. Okay. So according to this X, we know that there are 2 different outcomes, whether whether the customer asked for water or did not ask for water. So what we can do here is the binomial distribution. We can do binomial. Okay. How do we know if we want to use a binomial or a Poisson distribution? Okay. If we want to use a Poisson distribution to approximate a binomial distribution, the value of n should be big. Okay. Again, if we want to use a Poisson distribution to approximate a binomial distribution, okay, the number of n must be big. Okay. If you remember yesterday, we talked about n must be more than 30. Okay. So if you want to use a Poisson distribution, n must be more than 30, and n multiplied by p must be less than 5. Okay. In this case, in this question, we have a random sample of 10. So our n is equal to 10. So our n is not more than 30. So this condition is not satisfied. So we cannot use a Poisson distribution to estimate this binomial distribution. Okay. So we are going to stick with using a binomial distribution. Okay. Alright, so let's continue with a binomial distribution. So if a random sample n, okay, for a binomial distribution, we need to have how many terms that we need to know. So we need to know n and also pi. So our n we know that is 10. Okay, n is 10. And what is pi? So pi is the probability of success. So we know that 3 out of 5 customers ask for water with their meal. So 3 out of 5 means that 3 out of 5, okay, 3 out of 5 is just equal to 0.6. So 0.6 is your probability of success. Okay. And then once you know about this, okay, once you know your n, or your pi, okay, these are called parameter. These are called parameter. Okay, you need to know lah. If you're using a certain kind of distribution, what kind of parameter that you need to know. In case of binomial, you need to know what is the n and what is the pi. If you are using a Poisson, distribution, what do we need to know? We need to know the lambda or the mean. Okay, so the lambda here is the parameter for the Poisson distribution. Later we're also going to take a look at the normal distribution. So for normal distribution, what is the parameter for the normal distribution? So you also need to know about that. Okay, so uh, 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 okay, so and then you can answer the questions lah. But here, see the another important thing is that your pi here, okay, your pi here is 0.6. Your pi is equal to 0.6. Is more than 0.5. If it's more than 0.5, okay, and if the table does not give you the value that is more than 0.5, you need to find the inverse of it. Okay, you need to find the inverse of it. So instead of working with x, where x is the number of customers who ask water with their meal, we are going to look at y. Okay, what is y? Y is the number of customers who not ask for water with their meal. Okay, so we need to find did not ask for water with their meal. Okay, so if we're using y, so x here, the follow binomial with n equals to 10 and pi equals to 0.6. So if we follow y, so y will still follow a binomial distribution, but now n is still the same, n will still be 10, but our pi, or the probability that the customer did not ask for water, is 1 minus 0.6. So 1 minus 0.6 is equal to 0.4. Okay, so now we can solve this problem lah. Okay, now we can solve this problem. Okay. Okay, so that for this question, okay, I'll let you guys solve it by yourself. Let's take a look at another question for now. Okay, for another question, this one is from 2020 and 2021. Okay, for this question, again, if you see that the question wants to find the probability that something, okay, or find the probability that something, okay, okay, so you know that you need to follow some kind of distribution. So how do you know that which distribution that you need to follow? Okay, so here let's read the question. The average number of customers arrive at the registration counter is 4 people in every 5 minutes. So it is given this thing, 4 people every 5 minutes, and also stated that the average number. So if we're talking about an interval, okay, if we're talking about an interval, any time interval, in this case every 5 minutes, you know that we are dealing with the Poisson distribution. Okay, if you remember, we're talking about Poisson distribution is the probability, okay, of something happening in an interval of time. So here it will be very nice if you follow a Poisson distribution. So what is the mean? Okay, remember, for a Poisson distribution we have a parameter. So what is the parameter? The parameter is the mean. Okay, from lambda. So what is the lambda here? What is the average here? The average is 4 people. So it will follow a Poisson distribution with mean equals to 4. So what is our x here? So our x is, so read the question again, the average number of customers to arrive at the registration counter. X, the number of people, customers arrive at the register counter. Okay, this x, and your x follow a Poisson distribution with mean equals to 4. Okay. So once you get the distribution, it should be easier for you to proceed. Okay, because you will not be confused on which table you want to follow. Because later in the exam, right? Later in the exam, you will be given all different kinds of table. You will be given the Poisson table, you will binomial table, you also be given the normal table. Okay, so it might get confusing on which table that you want to use. So first, let's establish which distribution that you need to use in that particular question. In this case, we are using a Poisson distribution, so you will only need to refer to the Poisson table. Do not get confused which table that you want to use. And then find the probability that exactly 2 customers arrive in a 1 minute period. Okay, so here for the first question, you want to find the probability of the exactly 2 customers. So there are 2 different methods that you can use. Whether you can use the table. So in this case, the exactly 2 customers. Okay, Px equal to 2. I think okay, hold on. In this case, the question wants you to find to arrive in a 1 minute period. Okay, 1 minute period. But the question stated that there are 4 people every 5 minutes. Okay, so what you need to do is you also need to clarify here. Okay, so what is X? X is the number of customers arrive at the register counter every 5 minutes. Okay. So if the question asks for the probability that exactly 2 customers arrive in a 1 minute period, so let's do Y. So Y will be the number of customers to arrive at the registration counter every 1 minute. Hold on. Okay. So we have Y. So X here will follow a Poisson distribution of 4. So how about Y? Y will still follow a Poisson distribution, but it will have a different mean. Okay, we have a different mean. So we have an average of 4 every 5 minutes. So what if we have every 1 minute? So we just divide 4 with 5. Okay, 4 divided by 5, which means Y now follow a Poisson distribution of 0.8. Now we can solve this question. Okay, question wants to find the probability that exactly customers. Okay, exactly 2 customers. Oh, not X. Okay, we are now dealing with Y. Okay, so now we have 2 methods to solve this problem, either using a binomial table. If you want to use a binomial table, this will become probability of Y less than or equal to 2 minus with probability of Y less than or equal to 1. Okay, one book, set the properties again on 9. So the is A. Okay. So if you want to find the exact point, just find the probability on the exact point, if probability on the exact point minus with the one below it. So Py less than or equal to 2 minus with Py less than or equal to 1. Okay. So you can find the values in the Poisson table here, and then you get the answer. Okay. Or you can just straight away use the probability distribution. Okay. So probability distribution for a Poisson distribution, okay, is given by E to the power of negative lambda. So negative lambda is negative 0.8. And then lambda 0.8 the power of 2. Okay, power of x, which is power of 2. And divide with 2 factorial. Divide with x factorial. So here we'll still get the same answer as before. Okay, no matter lah whichever method that you use. Okay, whether you want to use the table or you want to use the probability distribution for person. Okay, remember this one is for person. So do not get confused to use a different probability distribution. Okay, that's why this is very important for you to detect first, for you to identify first which distribution that you need to use. Okay, and then same goes for question 2. Okay, for question 2, for 15 seconds. So you need to find what is the mean. That's the new mean. If y, I say that we have z. Okay, z is the number of customers arrive at the registration counter every 15 seconds. Okay, so you need to find the mean and then find the distribution lah. And then, okay, the same goes for question 3. Okay, for question B, a man is trying to persuade people to join an organization. He knows that the probability of being successful in persuading a person at random to join is 0.02. Then continue, one day he tries 100 people. Okay, this is the one hint. Okay, the first hint is that we have n. Okay, this one is n. So n is equal to 100, which is way more than 30. So we know okay, so we know that here we might need to use a Poisson distribution to approximate the binomial distribution. Okay, so yeah, so in the question it's stated that by using the Poisson approximation to the binomial, find the probability that he can recruit at least one person. Okay, so here if the question did not state this part. Okay, what if the question does not state this part? So you know that n is more than 30. Okay, remember that if you want to use a Poisson distribution to approximate the binomial distribution, you must have n more than or equal to 30. N and p less than 5. So here n is 100, which is way more than 30. So the first condition is satisfied. And here we have the p, okay, which is 0.02. So if you multiply 0.02 with 100, get 100 multiplied with 0.2. So here you'll get 2. So 2 is less than 5. So the second condition will also be satisfied. So here, even if the question doesn't state that by using the Poisson approximation to the binomial, okay, you know that we can use a Poisson distribution. Okay, why? Because these two conditions are satisfied. Okay, so that's how you identify for each of the question how which distribution that you want to use. Okay, based on the information. Okay, again based on the information. So for this question we have the word average and we also have the interval. For the question B, we know that n is big. N is big, we can approximate using Poisson distribution. Here, if n is small, we can just use a binomial distribution straight away. Okay, so is there any question about this? How to identify the distribution? If there's no question, one more thing. Okay, so here, I think yesterday I said a different thing. So for this question, right? For this question, it said that it's between 3 and 8 customers. Okay, so if it is something between 3 and 8 customers, and if we have a discrete distribution, this is accountable. So between 3 and 8 will not include 3 and 8. Okay, between 3 and 8. So if you have like a number line, right? So you have 3, 4, 5, 6, 7, and 8. Okay. If the question stated that it is between 3 and 8, so it will not include 3, it will not include 8. So whatever you are calculating is only 4, 5, 6, and 7. It will not include 3 and 8. I think yesterday I included 3 and 8, so please do not follow that. Correct that. It will only include 4, 5, 6, and 7. Okay, so if there's a word between, okay, between something and something, so that thing will not be included, not be included. Okay, okay. So try it yourself first for this question. Okay, try it yourself for this question first, and we'll discuss in a question for question A, one to the answers is here. Okay, so for question A, if a random sample of 10, okay, and we know that n is 10 of customers is selected, find the probability that exactly 6 customers ask for water with their meal. Okay, so here we know that x is population. Okay, x is the number of customers who ask water, ask, ask water with their meal. Okay, so x follow a binomial distribution with n equals to 10 and pi equals to 0.6. Okay, so what we want to find here for question 1 is the probability that exactly 6x equal to 6. Okay, x equal to 6. So here you can just straight away use your probability distribution. Okay, if you want to use your probability distribution, there's no problem. So you can just use this and answer process. So this one is binomial distribution, right? So 10 to 6, then 0.6 to the power of 6, multiply with 0.4 to the power of 10 minus 6 equal to 4. So here you just straight away get the answer of 0.2508. Or you can also, okay, here you cannot use your binomial distribution. You cannot use your binomial distribution table because our value of pi here is more than 0.5. Check your binomial table. You do not have the value of pi or p more than 0.5. Okay, so you cannot use this table. So you can either just use your binomial distribution, or if you still want to use the table, what you can do is you use y, use the inverse of x. Okay, so px equal to 6 is also equals to p of y equals to 10 minus 6. Minus 6 is equal to 4. Okay, this is the properties from page 112. Okay, so if you want to use py equals to 4, okay, you also have two different methods to do this. Either you just straight away use the probability distribution, so it will be 10, 4. So here our pi is 0.4, so 0.4 to the power of 4 multiplied with 0.6 to the power of 10 minus 4 equal to 6, which will still give you the same answer of 0.2508. Or from here, we want to find py equals to 4. This p of y less than or equal to 4 minus with p y less than or equal to 3. Okay, so here we can use our table. So for a binomial table, so we have 0.4, 0.4, and n is equal to 10. So scroll down to 10, 10, 0.4, and we want our x to be 4 and 3. Values are 0.6331. Have 0.631 minus with when y 3. When it's 3, it is 0.3823. 383. So here you will still get the same answer of 0.508. Okay, see here, there are multiple methods that you can use. Okay, so whichever methods that you use, you'll get the same answer. Okay, whether you just want to straight ahead use uh, the X, okay, where X is the number of customers who ask water with their meal. Okay, you can use this one straight away because it's just asking for the exact probability. So it will be easier lah. Just use your probability distribution like this. Or you can change X into Y. Okay, change X into Y, where Y is the number of customers who did not ask water with their meal. Okay, so since it is asking for exactly, okay, Y equals to exactly 4, so you can just straight away use the probability distribution. Or you can also use the table. So if you want to use the table to find the exact number, okay, you can minus Y less than or equal to 4 minus with Y less than or equal to 3. So you'll get the same answer here. Okay, so there are multiple methods that you can use. Okay. Any questions here? Only for question 1. Okay, same goes for question number 2. For question number 2, we want to find the probability that less than 9 customers ask for water. Okay, less than 9 customers ask for water means that you need to find the probability when X is less than 9. Okay, the probability of X less than 9. So this one can just be equal to probability of X less than or equal to 8. Okay, you can do this, but you cannot use the table because we have our pi is 0.6. So we can convert into the inverse, which is y. Okay, so this one will be equal to when p x less than 9. So it is p of y more than 1. Okay, or you can also, instead of, if you still don't want to use y, okay, if you still want to use x, you can use px less than or 8. Okay, how? So this one lah. I'm not supposed to show you guys, but whatever. So if you want to find using px less than 9, okay, so you can just use minus 1. 1 is the total, right? Total probability. Minus with px equal to 9, minus with px equal to 10. And then you find each of them by using the probability distribution. Okay, so you can also do this way. Or you can convert it into the inverse, which is y. So y will be more than 1. Okay. And then lastly, for question number 3 over here, so for question number 3, so between 3 and 8 customer do not ask for water with their meal. So here it is do not, yeah. So be very careful. So for question number 3, what you need to find is actually p of 3 not include y and then the 8. Okay, one. Okay, y here is not x. Okay, it's y because y is the number of customer who did not ask for water. Okay, the previous question in question 1 and 2, it is they ask for water, but in question 3 they do not ask for water. So in the middle here should be y. Okay. So is there any questions about this particular question? If there's no questions, I already give the slide in the WhatsApp group, so you guys can continue. You guys can continue to do the exercise in the slide, or you guys can also do the exercise that I gave yesterday. Okay, for the exercise that I gave yesterday, I'll give the answer in a bit, so you guys can probably check your answer whether it's correct or not, and then you can send it through Google Classroom. So if there's no question, I'll leave you guys. Okay. Just as a reminder again, your test two will be on 10th of July. It's on your week eight. On your week eight, start at 8:30 until 10. So this one will be chapter 3 and chapter 4. And for your quiz two, will be on this Sunday. Okay, this Sunday, 30th of 30th of June. Okay. Alright, so if there's no more questions, thank you so much for coming. And I'm really sorry for this to be having an online class. Okay. Hope it doesn't inconvenience you guys too much. Okay. So if there's nothing else, see you guys on Sunday in class. Hopefully with a better me. And yeah, have a great weekend everyone. Thank you.